So in this video, we're going to talk about correlation. Two continuous numerical variables, so that's two values for two different variables for every subject, and we want to see how the changes in one affect the changes in the other. And so we're going to talk about Pearson's correlation coefficient. We see our data set with three columns. The first column is ID, that's just a unique number to identify each of the subjects in our study. A second variable here is our first continuous numerical variable called independent. It's continuous numerical as mentioned, as is the second variable which we call dependent. All that matters here is that we have two continuous numerical variables. So as is customary with our data science approach to using Microsoft Excel, I'm going to select all the data. So I'm just clicking in any of the cells. I'm going to hold down Command on a Mac or Control on a Windows PC and hit the A key for all. So I'm selecting everything, and then Command or Control C to copy. I see the marching ants. As always, we're going to make a new sheet. I'm going to go to paste, that little drop down next to the paste button, and select paste values. And let's just do that for a second sheet as well. Little drop down next to the paste button, all the way down, paste values. So I've got two new sheets. I'm going to call this first sheet copy. So I'll just double click on the sheet name and call it copy. Remember, this is the one that I can make changes to, but this original one that I call data, I leave that one intact. It's just a copy that I save in case I mess anything up. I can always come back to this original. Now the second copy that I made, this is the copy that I want, or the sheet that I want to use to do my calculations with respect to correlation. So let's call it correlation. As is also customary to our data science approach to using Microsoft Excel, I'm going to click in any of these cells. I'm going to go to insert and then third little button across, table. Lo and behold, my table does have headers. That's selected. I'm going to click OK, and I've turned my data into a table. It just makes it very easy to work with data in tabular form. Now, we have not used Microsoft Excel to create any kind of chart, but I think these pairs of numerical variables really lend themselves to creating a chart. And the chart that we're going to create is called a scatter plot. So I'm going to go to insert, and I see the drop down next to recommended plots. Look at this first one. That's the one I'm going to go for. Let's increase the size a bit. And let's put it right at the top. By default, Excel has done a great job, but we can make sure that the chart is to our liking. I'm clicking in the chart, then selecting the right mouse button, and I'm going to go down to select data. What I want to make sure is if we look at X values and Y values, that it has chosen the correct variable for the horizontal and the vertical axis. And so if I look at the X values, I see it is in cell B2 all the way down till the end of that B column. And for Y, it's down the C column. So it's correctly chosen the independent variable to be on my horizontal axis and the dependent variable to be on my vertical axis. That's exactly what I wanted. And we can see the clear trend here. As the values on the independent variable, that's the horizontal axis values, as they increase, look, it goes from 10, 15, 20, 25. So we see a corresponding increase in the y-axis or the dependent variable values. We see it go up 20, 30, 40, etc. So I'm going to call this positive correlation. As my independent variable value increases, so does the values of my dependent variable. Now, Microsoft Excel does allow me to manipulate this plot to my liking, but this is not a course on creating plots in Microsoft Excel. What we're interested in here is the correlation, and more specifically, Pearson's correlation coefficient. There we go. I'm just going to increase the size of the cell E by clicking in between E and F. And so we're ready to calculate Pearson's correlation coefficient. Remember, it is on an interval from -1 to +1. The positive values being positive correlation, as we can see in our chart here. And then negative values from 0 to -1, that is negative correlation. As the independent variable increases, the dependent variable values would decrease. Remember, 0 is the value under our null hypothesis. We think that the population correlation is 0 under the null hypothesis. Values between -0.5 and +0.5 would be considered weak correlation. Values between -0.5 and -0.8 or +0.5 to +0.8 would be moderately strong correlation. And then values from -0.8 to -1 or +0.8 to +1 would be strong correlation. We just have to add the positive and negative. So let's calculate Pearson's correlation coefficient. That's going to equal COR, and we see it comes up there, CORREL, and it wants the first array and the second array. So it just wants the numbers. So I'm going to go down to B2 all the way there. I'm going to hold down Shift, Command or Control, hold down those two buttons, and then the downward arrow key. That'll jump me all the way to the bottom. Then I'm going to say comma because it wants the second array. I'll go all the way to the top, and now I'm going to click in cell C2, hold down Shift and Command or Shift and Control, and then the downward arrow key. That selects all the values in the dependent variable. I'm going to close my parentheses and hit return. And there we see a very strong positive correlation of 0.933. Indeed, it is positive, as we can see from our graph, and it's also very tightly grouped. We don't see these markers all over the show. They're very tightly grouped. Now we can also use the built-in data analysis capabilities of Microsoft Excel to do this work for us. I'm going to click in any one of the cells in the table. I'm going to go to Data and then Data Analysis. And near the top we see Correlation. Let's select that and hit OK. It's going to ask me for the input range, so it wants all of the values for both variables. So I'm going to hit the Selector button. All the way to the top, I'll click on Independent, hold down Shift and right arrow to select Dependent. Then also hold down my Control or Command key and then down arrow. Everything is selected, as you can see, the independent variable and the dependent variable. I'll expand again. Now I just have to make sure that this group by, that we have columns selected because we have 2 columns of data. And I'm going to say labels in the first row. Now the output range, I want that to be in the sheet. Remember, the sheet is all about correlation. So I'm going to hit the selector button. Let's go all the way to the top and let's put it there. I'm going to put it in E29. Let's hit the expand button again. And we can hit OK. And there we can see the correlation. Now look, between independent and independent, or between dependent and dependent, we have perfect positive correlation, of course. But what we want is this cross diagonal. And there we see our value, 0.933. Now we can do a t-test. Remember, under the null hypothesis, we have that the population correlation is 0. Now what we will need is the following: an alpha value, a sample size, degrees of freedom, a critical value, a standard error, a t-statistic, and then finally a p-value. Now let's select an alpha value of 0.05. Now let's look at the sample size. If I go down right to the bottom, remember the first row was our variable names. It goes down to row 306, so we actually have 305 subjects in our data. So I can put 305 right there. That's a manual way of doing it. The degrees of freedom for this t-test equals the sample size minus 2. I've got 2 variables there. And so we have 303 degrees of freedom. Let's calculate a critical value for this t-distribution. That's going to be t.inv. Now this is two-tailed, so I'm going to say 1 minus alpha divided by 2. Then comma, my degrees of freedom is 303, close my parentheses, and we see a critical value of 1.9678241. Now the standard error for this t-statistic is very easy. That's going to be the square root. So I'm going to say equal SQRT, and then I'm going to open parentheses. What I want to do is I want to go up to the formula bar because there's quite a few things I want to do, and I want to use my left and right and up and down arrow keys, and you can't do that within a cell because then it's going to do cell references. So let me close my parentheses there. Let's go inside the parentheses again because I've got a fraction there. So I'm going to open close parentheses divided by open close parentheses, just to indicate that I have a numerator and a denominator. In the numerator, I'm going to have 1 minus the correlation coefficient that we have right there squared. And then I'm just going to click between that second set, the denominator set of parentheses, and there we need our degrees of freedom. So 303, click on that, and we have our standard error. To calculate the t-statistic, that's going to equal, we take the correlation coefficient. We're supposed to subtract 0 from that, but that just leaves us with a correlation coefficient divided by the standard error, and we see a very large t-statistic, 45. That is much, much bigger than our critical value of 1.9678241. And in this case, then we reject the null hypothesis that the population coefficient or correlation coefficient is 0. It's indeed not 0. Now the p-value is going to be very small. In actual fact, by rounding, Microsoft Excel is just going to give us a 0. Let's do that. That's equal t.dist. Now I'm going to do this in a couple of steps. So let's do x, that was our statistic, 45, comma, our degrees of freedom we have right there, 303, comma, and we want cumulative. Let's do that, and we see that's nearly 1, but that's all the way from the lower tail, that's negative infinity, all the way up to 45. That's not what we want, so let's go up to the formula bar right at the beginning, and we're going to say 1 minus that, and still we are not done. We have to put all of this in parentheses, front and back, and we've got to multiply that by 2. Now the value is still 0. By rounding, there are so many zeros after the decimal place that Microsoft Excel is just going to round this off to a 0. That is because our t-statistic is so large. And there we go. We've done correlation, we understood correlation, and we've done a t-test just to see if the population correlation coefficient is 0. And indeed, we see we can reject that null hypothesis. It is not 0.